Hello, everyone. My name is Seth Itzkan. I'm the co-founder and co-director of Soil for Climate. My colleague Carl Tiedemann and I started this nonprofit in 2015, and our objective is to advocate for soil as a climate solution and to help enact the policies, practices, and paradigms, if you will, to make it happen. And it is a great honor for me to be here today in this 4p1000 session. Oh, I'm sorry, I should speak slower for the translators. And I want to give a special nod of appreciation to Dr. Paul Liu of 4p1000 and to Gabrielle Bastine of the Regeneration Canada program. And they're the hosts for this. And I also want to give a special shout out to the Soil for Climate Facebook group members who are watching today. Thank you for being here. So I'm going to wear two hats, if you will, today. First is sort of the science hat to talk about soil as a climate solution, but at a perspective that maybe is different than you've heard, and also to talk about the advocacy of our nonprofit, and particularly our Kenya project. Some of you know we're getting involved in a project in Kenya now, and we're really excited about that. That is great hope for us. So let me move on to the next slide. Basically, any opportunity I have to show the picture of the whole Earth, I'm going to do so. We're really fortunate as a species. We're fortunate to have this picture. It was serendipitous. It happened to be a whole Earth when it was taken, and it tells quite a bit. Certainly, we are mostly an ocean planet. That's one of the stories that this picture tells. But on the part of the planet that is land, most of it is grasslands. So I want you to sort of get that. We're mostly a grasslands planet on the part that is land, and the grasslands play a huge role in regulating the climate. We'll get into more of that, of course. And so here you go. This is just a wonderful slide. I love to start with this. This is from an exhibit called Exposed, The Secret Life of Roots at the United States Botanical Garden. Excuse me. You can see just a cross-section of the grasslands there. It's just a perfect illustration, and you can see how deep the roots are. And this is a classic soil, a temperate grassland ecosystem, and a huge store of carbon. And this slide basically shows the magnitude of carbon that is in soil. 2,300 gigatons, 2,300 gigatons, yes, 2,300 billion tons. If you look in the lower left, it shows the carbon in soil. Obviously, there's too much to get into here with all the detail, but you get the point. We can talk about more of these later. This slide, basically what I want to get to here is not the actual numbers, but the sort of the sinks and sources and sinks. This is sort of that's the purpose of this slide, is to show that of the source of carbon that's coming from humans through emissions, there's only 3 sinks. Now the numbers have changed. It's already closer to 11 now in terms of the gigatons of carbon of emissions. But there's only 3 sinks. There's the oceans, the atmosphere, and what they call the terrestrial sphere. And 2 of them are bad. In the oceans, it becomes carbonic acid. In the atmosphere, of course, it creates the greenhouse effect. But on the land, the terrestrial sphere is a good thing. We want that, and we want more of that. So the answer to global warming, climate change, is really to reduce the 2 bad ones and to increase the better ones. So that's a sort of a simplified way of seeing it. And this is a paper from Susan Solomon from 2009 called The Irreversible Climate Change Due to Carbon Dioxide Emissions. Susan Solomon is a professor at MIT, Massachusetts Institute of Technology. And the key here is the phrase largely irreversible for 1,000 years after emissions stop. So she's making the point that even if we stop emissions, which we have to do, it continues to warm for 1,000 years at least. And then here's where the grass, and the bottom right is the thermal expansion. It's basically because the heat is getting trapped in the oceans. So the oceans is a huge part of the thermodynamics of the planet, and it will continue to expand and warm for at least 1,000 years, even after our emissions stop. And then the top left is the CO2 in terms of parts per million. This is a picture of Susan Solomon. Okay, now, 4 years later, the IPCC released this statement. A large fraction of anthropogenic climate change resulting from CO2 emissions is irreversible. I wonder where they got that word from, on a multi-century to millennial timescale. So clearly the IPCC is citing Susan Solomon, her 2009 paper. But look at this part that the IPCC added. Except in the case of a large net removal of CO2 from the atmosphere over a sustained period. You see, bang. They've added that second part of the sentence. It's largely irreversible, except in the case of a large net removal. And where is that large net removal? Well, of course, it's in soil. You can literally see it. I'm just going to try and go quickly here. Okay. Now, basically, we know what some of the best practices are for increasing soil carbon. I'll just go through these quickly. Reforestation, organics, no-till cover cropping, biochar. We don't hear enough of that, actually, but we need to hear more of it. And, of course, my favorite and the favorite of Soil for Climate is using livestock as a proxy for wild herds, and sort of the whole holistic planned grazing methodology, which we're big advocates for. And we're such big advocates for it because it is such a large part of the world. So much of the world is in a degraded grassland system, or even a system which is today we just call it desert. It used to be a thriving grassland ecosystem, or semi-arid grassland ecosystem, and it needs to be again, and the way to do that is with proper grazing. And so we've put a lot of effort into learning more about this, and I have personally been to the Africa Center for Holistic Management in Zimbabwe many times. I've lost track. I've been going there pretty regularly since 2011. And so I took this picture myself. Multi-species herds being managed in a way which replicates as a facsimile for the indigenous wild herds that these grasslands co-evolved with in the first place. And here you can see just a perfect example of the efficacy of this work. You can see the healthy grassland on one side of the fence and the desert on the other. You know, they just happen to put that fence right at the boundary of the grassland of the desert. Well, I call this the paradigm fence, because there really is a different paradigm in how we're thinking about land management. One is exacerbating global warming, the other is mitigating it. And you can see that from space. So that previous slide, I'll go back to that. This is from Google Earth. You can literally see it from space. You can see the efficacy of this from space. And so personally, I just lose a little patience when I hear people still questioning the efficacy of the savory work and holistic plant grazing. It's the most obvious thing in the world. It's obvious on the ground. It's obvious in space. It clearly works. We need to do much more of it. Here's examples of the restoration in process over time. So starting from 2014 and going to 2013. Now these pictures are taken in the dry season. What's important is not the color of the cover. You know, so if it's rainy, it may be green. The fact is of the cover itself. The fact that you went from a desert situation to a situation which is 100% covered in grass. That's the germane piece of information in this slide. And then so here's sort of just a sort of a close-up, and then that's me at this spot itself after the restoration. And then, okay, so just sort of showing off here, but it really is a joy, frankly, speaking from my heart. It is a joy to stand in a place that is recovered. And there's high climax grass here. It's called Panicum maximum. It's called a high succession grass. It only grows in a really healthy ecosystem. So it's an indicator of healthy soil, which of course means that there's more carbon in the soil and there's more water cycles happening, small water cycles. So it's a success story, and of course there's more food, and the cows are fatter, and it's a win-win-win. It's not just soil carbon. There are so many other dimensions by which it is a win. And then here's sort of another example. We call this the elbow site. You can see it sort of looks like an elbow there, that tree in the middle. And then here's the restoration. Again, okay, so I have 5 minutes. Thank you. So you get the point. We know that land can be recovered. This is Gabe Brown, is one of the sort of the hero practitioners in the United States. He's in North Dakota. He's improved the soil on his land from approximately 2% to as high as 8% soil organic matter. That's huge. I mean, that should be the cover of the New York Times. Like, everyone in the world should know that he's done that, and he's done it with holistic plant grazing and the Savory method, and integrated with cover crops and with a soy rotation. So when my wife... Oh, I'm sorry. Okay, we don't have time to hear the video. Okay, and then so here, just some number crunching here. If 8% soil organic matter is 76 tons of carbon per acre to 12 inches, and that's a 57 ton per acre increase over the 2% that he started with. So he's almost 60 tons per acre he's added to his ranch over about 5,000 acres, 14,000 tons per year, by the way. So it's an amazing success story. Here we get into the science, and as usual, we don't have time. But the key thing you want to see here is that the temperatures have decreased significantly on a planet scale over the last 30 to 40 million years because of the evolution of grasslands and ruminants and ungulates. So that coevolution of basically grazing mammals and grassland soil is what has led to the cooling of the planet over the last 30 to 40 million years. And then the last 10,000 years or so, at the far right there where it gets kind of flat, that's called the Holocene. And we actually have prevented an ice age from coming. And then that's because of agriculture. So ruminants and grasslands created soils, I got it, 2 minutes, which cooled the planet. But then in the last 10,000 years, agriculture has helped keep the planet warm when it should have cooled. And I apologize that I won't have time to go into all the science here. But these are just some seminal papers. Greg Ritalik, Global Cooling by Grassland Soils, the Geological Past and Near Future. Please familiarize yourself with this work. He's basically showing what I just said. The evolution of grasslands and ruminants has led to global cooling over the last 30 to 40 million years. And then here's a paper by Zhang on showing the CO2 decrease over the last 30 to 40 million years, corresponding also with the evolution of ruminants and grasslands. And then here's a slide that Carl Tiedemann and I made together, sort of a composite slide showing the work of Ritalik and Zhang together. And then you can really see, how it all works. And don't have time to get into the science here anymore. Basically, we've been holding off an ice age for 10,000 years. Let me just talk very quickly about, our organization that we love. We're an advocacy group, and we're with Bill McKibben, of course, and we stand with the traditional climate movement, if you will, the decarbonization of the energy system movement, while we also advocate for the recarbonization of soil. So decarbonization of energy, recarbonization of soil, and this is us around the world, including at COP21, the Paris Climate Accords, and just want to, working with kids, just trying to make it sort of fun. We do poetry, we do music, as well as the hardcore science. And so our project in Kenya, it's called Enkaposaligi. It stands for the Promised Land in Maasai. We're working with a Maasai village and a Maasai herder to do holistic plant grazing there. And so we've done the savory training. Okay, it's over. Well, all right, let me just end on this. I just love that we are doing this Kenya project, and I thank everybody who has helped support it. And this is my colleague, Dalmas Tiampati's son. His name is Chichi Tiampati, and they've adopted me into the family, and that's my hope for the future. Thank you, everyone.
Thank you very much, Seth. Very sorry we have a limited time. We can hear you for ages, but well, we have to stop at once. Your presentation will be available for all the people who are participating, and that will be the complete set. Of course, we will miss your explanation, but there are some beautiful pictures that don't need any comment, and also some sketch and graph that also explain themselves. So thank you very much, Seth, for that presentation, and stay with us for some question at the end. So I just would like to remind our participants that we will be